Hello and welcome back to Azure Terraformer. Today I have a fun little episode where we're doing some gymnastics in HCL. This came up on an internal Microsoft Terraform call. It happens every week on Tuesdays. And I try and show up whenever I can, whenever I don't have conflicting meetings. There's usually some interesting announcements from David Wright, who I'd love to have on the show anytime, David, anytime you're interested. Let's make that happen. That'd be fun. Look at me calling this a show. This is just me in front of a camera coding. I don't know. I guess it's a show. So anyways, this week we had a really good brain buster that was presented by one of my colleagues at Microsoft. He was working with Zscaler, and apparently he was trying to whitelist some IP addresses. That's the reasons that he told me why he was trying to accomplish this. And he had this big old nasty JSON file that Zscaler published. A lot of services will publish IP ranges that you can expect incoming traffic from, or that you need to have outgoing traffic to in order for their service or appliance or whatever it may be to operate, to function. And so in situations where you have a very tight grip around your network traffic, maybe this is in Azure, maybe this is on-prem, there's this practice where on the firewall or on the edge of that network, you have to allow outbound traffic to certain IP ranges, or you might have to allow inbound traffic from certain IP ranges in order to do business with that service. So long story short, Zscaler publishes a whole bunch of IP ranges where their services are hosted. And then if you want your application or you want your code to be able to work with their services, then you need to open up either inbound or outbound traffic to these IP addresses or both. And so that's what he's trying to accomplish. The problem is this JSON file is a little hairy. So we're going to look at this JSON file and we're going to try and transform it into something that's more consumable so that somebody could go and create a bunch of firewall rules using Terraform from it. And so we're going to try and do this with HCL, because that was the original question. He's like, hey, should I do this in HCL? Can I do this in HCL? If I can, how can I? Is this even the right use case for HCL? And, we looked at this JSON and, David and I were looking at it and we're like, oh, I don't know, man, this JSON's pretty nasty. It's got some weird meta language inside some of these key nodes. It's pretty nasty. So anyways, we ultimately got to a solution. I just wanted to share that with you guys. But let's look at this problem together, and then I'll show you how I approach this problem and problems like this, because you do occasionally run into situations where there's some kind of wacky JSON or YAML or file that you need to parse and transform it into something actually useful so that you can iterate across it using a count or a for each meta argument. Before I get started, if you enjoyed my channel and you enjoyed content like this, please smash that like button and consider subscribing. Also consider channel membership. It's a new great way to show your support for the channel and to announce to the world officially that you are an Azure Terraformer. Without further ado, let's drop in the code and get started. So here's this JSON file, and you can see here that I have some semblance of a structure. I have this root, what appears to be a root node. If I collapse it, there's only one of them, right? So first step, find the root node. Check. Second step is kind of interrogate the structure here to see what's going on. So I think I found the data that I want, which is these IP ranges. And it looks like Abu Dhabi is a city, been there, and it's on this continent. Okay. And so a city can have apparently one or more of these things, right? Because if I collapse that, you can see that this little object with the curlies is inside of an array. And this object has this range attribute on it. Now, lat long, that looks mighty interesting, but I don't care about this. And all these other attributes, I really don't care either. Because if I'm going to be extracting and generating IP firewall rules that basically allow or deny traffic to certain IP blocks. In this case, this is /23. I don't have CIDR memorized. What is that? Is that 512? I think /22 might be a 1024. So maybe this is 512. And then /24 is 256. Okay. So I memorize /24. It's 256. And then /22 is 1024. Because I commonly use /22 when I do small little ditties. Anyways, so that's what this is. This is the IP range that I want to get access to. Abu Dhabi has one of them. Oh, look at this. Amsterdam. I don't know how Amsterdam and Abu Dhabi are on the same continent, but okay. Amsterdam actually has 1, 2, 3, a whole bunch. Okay. So I think we found kind of the first structure. So I've got to jump to the root node, to the continent, and then for each city, I need to grab an array of IP ranges, right? And so now the one of the requirements was that the rule should have a name that concatenates the continent and the city. So we'll kind of go, and maybe on the side here I'll show what the expected result is.
A few moments later.
So I'm going to stub out some sample data of what success looks like. And so in my array, I want to have a single object, and I want it to have a display name, and I want it to have the continent concatenated with the city. And then I want to have my IP ranges. And this will be an array. If you've done software development or you've done software development testing, SDET, basically what we're doing is we're creating an expected result from an actual input. So this is the actual input, right? And this is what we want to get out of it. So a traditional software developer is going to write a unit test that's going to take this JSON and it's going to produce this HCL, right? In this case, right? Expected input, expected output. It's basically like what a unit test is. In a unit test, you have some controlled inputs. You then state what you want your code to actually output at the end, given that controlled input. And then you assert that what your code outputs is what success looks like. So we should probably add another one on here just so that it's super clear what we're doing here. So we do want an array of these things. And I want this, I somehow managed to misspell display name. And display name is going to be EMEA, and it's going to be Amsterdam. Been there as well. But I feel like I'm more into The Hague. In terms of water cities, I really like Venice. Venice is amazing. No knocks on Amsterdam. I'm gonna go back. I'm gonna give it another shot. But I really like The Hague. The Hague was a beautiful city. Did not get to see the girl with the pearl earring though. That painting. Very sad about that. Long story. And so right here, I'm not gonna boil the ocean here, but you kind of get the drift of what's going on here. We need to have EMEA. Now, if this were a true unit test case, like I would absolutely, have all of the Amsterdam IP ranges in there, but it kind of seems like there's quite a lot of them. So I don't know if I want to deal with that right now. So this kind of helps me understand like what the objective is in terms of something that's going to be easily usable by somebody that's trying to for each across these, not for each in this case, but count across these. I could easily turn this into a map in for each, but that's neither here nor there. So now the question is, how can I get this JSON into this what success looks like? So the first thing that I need to do is I want to load this, the content of this file into Terraform, right? So I can do that just by declaring a local and saying raw content equals file, and then we're just going to pull my, it looks like GitHub Actions is, it looks like GitHub GitHub Copilot is trying to help me out and failing miserably. I don't want content.md. I want zscaler.json. Okay. Now, just to see, and what I should probably do is I should probably do a JSON decode. So JSON decode. It's already JSON. So it's already JSON. So I need to decode it into an object structure. Okay, so now I've got that. Now let's go look at this. So I'm just going to output the raw content. So that produced a huge, super long output because basically I'm taking this huge, super long JSON file, which this thing is, good Lord, 4,000 lines long. And I'm doing that. So yeah, I suppose, this is progress. Now, the next step that I want to do is I want to go spear fishing. Okay. This is what I call if I have this huge object and I want to go grab an object out of it so I can go look at it a little closer. So first of all, I want to go find this zscaler.net guy. So again, spear fishing. I'm taking my spear and I'm throwing it into a huge pool of water, i.e. this big JSON, object graph. And I'm trying to grab a specific object or fish out of that pool of water. So that's where the metaphor comes from. So now let's go get the root node. So I'm going to actually reference the raw content. Now, raw content is a map. So I can just reference the key of that object and pull out that root node. So I know it's a map because the little curly implies that, and the object in the map has a key, right? There just happens to be a map of one object, right? Now, zscaler, this object in and of itself is a map, right? But that map has multiple elements within it, actually 3, EMEA, Americas, and APAC, right? So with my spearfishing, I can get closer and closer to the bottom of this object graph just by accessing elements from the map in order to interrogate their internal structure. Let's output the root node. Now, raw content takes up a lot of space, so I'm just gonna comment that out for the time being. Otherwise, we're gonna get crushed. So now, the root node is still a lot of stuff. So it's kind of hard to tell like what exactly we're looking at. But there we go. So the root node, now I just have the continents. So I'm like closer to the stuff that I want to iterate across, right? Because I don't want to iterate across this thing because there's only one of them. What's the point of that? So it wouldn't make a whole lot of sense to do that. So now that I have the root node, the question is, how can I parse this stuff to get the outputs that I want? So let's try and create a for expression, expected output. And we'll start building it, right? So now I'm just going to say for continent, because I have continents in this collection. And because I know a continent is a map, continent is actually the key. Now, what would be the child? I guess it would be a collection of another map of cities, right? So let's do continent and cities in local.root node. So let's start with just the display name, and let's see if we can just get continent, and then maybe city. Let's do some string interpolation here. So continent is the key, and then I'll do whack and I'll say city. Let's break this down. I have a for expression. The for expression is outputting an array because I have these, nice little square brackets that are wrapping it. It's not the most obvious of syntax, but okay. Now I want to output the expected. So I'm not going to output the root node anymore. I want to output the expected output. Let's just see how we're progressing here. I'm also going to comment out the root node because I don't want to see it, really. Okay, so we have a problem. Oh yeah, well, we have a problem. City doesn't actually exist. I am not iterating across the cities yet. So let's leave this off for now and let's just see what this produces. I guess I don't really need string interpolation. Did I manage to misspell continent? Having some great time. Okay, so my expected output is the 3 objects within my content, and you can see my expected output is a lot simpler now. But we're not done yet because we haven't even gotten close to the actual data that we want, which is the IP addresses, the address spaces for each city. I need to do a nested for because this cities is actually a map. So the structure of my current for expression is that for this key and this value in this map, I want you to output an object, which is what I'm doing. But I don't want to output an object anymore. I need to actually output a for expression. So for each continent, I want to execute another for expression, which is going to output an object. So I need to delete this because that's the output of the for expression. And I want to replace that with an array because I do want to output yet another array. So this is another for expression that's outputting an array. Oh, look at this, and it's already kind of helping me out. Yeah, this actually doesn't look that bad. So I do want city, and then I'll just call it detail. And then it is in the cities map. And then I'm going to output an object. Now the object, I'm going to bring back my display name, and I'm going to concatenate the display name using the continent. Let's see if I can spell it correctly. And now I have the city. So now let's see what this thing outputs. So we're getting a little bit better. We have this kind of weird concatenation happening with continent colon prefix and city colon prefix, which is not desirable. And we have a whole bunch of cruft because we actually have an array around each continent. Because we have nested for loops, we're actually creating this array of an array. Now I can fix this by just using a flatten method. That's going to take these nested arrays and construct a simpler structure. But let me see if I can, and there's actually a change in this plan. There we go. So notice I have 2 arrays nested. Now that I made this change to flatten, I'm only going to have 1 array. And this 1 array is exactly what I want. So that flatten of those nested for expressions is really helping me out here to create a single array that I can iterate across. That only works if both of your for expressions are outputting lists. So it's really imperative that you make sure that you are using the square brackets for your nested expressions. So now let's see what I can do with this city stuff. So first of all, if I go look at the JSON file, where's this continent stuff coming from? It's really, earlier I mentioned there's a little bit of a meta language inside here. So these nodes within this JSON, it's almost like an XML tag, right? Like it, you have an XML tag that like is different for each node. So here I would have like a continent tag, but it's really this continent colon prefix. So this does make it look really like a very difficult problem, but it actually isn't that hard to fix this. Because all I have to do, this continent right here is really the string of continent colon EMEA. All of the continents are prefixed with continent space colon space, which does make it easier for us to process. I just need to use a function called replace. I'm going to replace it on content. So what do I want to replace in this continent string? I want to replace this nastiness, and I want to just replace it with nothing. So now if I go run Terraform apply again, now my continents no longer have a prefix continent. Wonderful, right? Now I just need to do the same thing for my city.
A few moments later.
Now all I have to do is replace this space hyphen space with a slash, and I have a nice pretty name. There we go. So my display name is good. Now I need to populate an array of IP ranges. So if I go look at one of these guys, inside of that city, we have a list of objects, and they have a range attribute. And the range is really what I want to get. So what I got to do is on my output of this address block, what I need an address space, and that is going to be an array as well. So I need another for statement. But this time I'm not iterating across a map. I'm iterating across a list. And so what I'm going to be iterating across is the detail. And really this is probably should be plural because the cities have details. So for each detail within the details, does that make sense? For detail in details, now what I want to output is detail.range, which is the attribute on that detail object. And let's just say if detail.range is empty, let's not include it. So detail.range not equal to double quotes. There we go. So now I think we should be hitting pay dirt right about now. We are going to create an array of address spaces for each of the address ranges in that map. And there we have it. We even have some IPv6 stuff in here. Good job, Zscaler. And there we go. So we have Warsaw with quite a few. Vienna, Wien, been there. Tel Aviv, never been there. Stockholm, never been there. So I think this is what we want. So now that we have this, we can very easily go and construct resources that grab these address spaces and create rules for them. So I hope this was helpful. This was a fun brain buster that was presented at an internal Microsoft Terraform meeting, and we solved it in this meeting. It was really fun. So I hope at these meetings, my colleagues at Microsoft bring more of these brain busters so that we can solve these things together. Because I thought it was pretty cool use of the meeting. There's only so many announcements and so much slideware that we can do. So it'll be fun if we can do some brain busters at some of these meetings. We went from kind of this daunting task of, we have this crazy JSON. It's got weird, prefixes within the nodes, multiple data structures, very nested data structure. On this call, we went from, maybe you shouldn't do it in Terraform. Maybe you should do it outside of Terraform using JQ or something like that. And like on the call together, we basically wrote, 10 lines of code? And I'm being real generous because I'm including all the new lines for all the spaces. But really, when it all boils down to it, you're probably logical lines of code, 1, 2, 3, 4. 4 logical lines of code. The rest is just like boilerplate, curly braces, square braces, whatever. 4 lines of code, and you can parse this nasty JSON file and output this beautiful HCL array that you can then iterate across on resources within Terraform. So that's it. That's it for this episode. Anyways, I hope that was helpful. If you like this content, please smash that like button and consider subscribing. It really helps out a lot. And also consider channel membership. It's a great way to support the channel, to make sure that I can keep pumping out content like this. I just got my Azure build the other day, and I definitely need to work on some FinOps content to, batten down the hatches and make sure I'm not just burning cash, because I do all of my demo work on my own personal Azure subscriptions. And so sometimes I forget to, delete the VM. Sometimes I forget to hit the destroy, just like anybody else. And it costs me money. So this is a labor of love. Any support that you can give really helps out a lot, to counteract some of my Azure bills and all that. So I also have additional levels of engagement. So there's the Code Ninja Squad. So if you want to get first in line to my code reviews and work a little bit closer with me at that level, you can join as a Code Ninja. And also there is the Inner Circle, where if you want to have a 1-hour virtual one-on-one session with me each month, you can join the inner circle, and that will be available to you. And we can sit down one-on-one and work through your problems together. Anyways, that's it from me. This is the Azure Terraformer, signing off.